He knows a lot about the science stuff. Professor Dave explains.
Let's take a look at a practice problem regarding quantum numbers and electron configurations. So the question is, for a neutral atom of arsenic, first, what is its ground state electron configuration? And two, what quantum numbers would be assigned to the electrons in its highest energy subshell? So if this sounds confusing, go ahead and check out my tutorial on quantum numbers and electron configuration. It's very thorough and it will elucidate all of these concepts for you. So once all of that makes sense, give this one a try. So the first thing we have to do is get the electron configuration of arsenic. So let's find arsenic. There it is, number 33 on the periodic table. So let's start working through the blocks of the periodic table. If we start in the first row, that gives us 1s2. Those are the electrons for hydrogen and helium. Then moving to the second period, we have 2s2, 2p6. Moving to the third period, we have 3s2, 3p6. Moving to the fourth period, we have 4s2. Then we go through the D block, and remember that the D block is one behind the S and P blocks, so we have 3d10. And then to get to arsenic, we're moving through the P block. We have 4p3, because it's the third element through the P block. So that will be the ground state electron configuration for arsenic. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. We can abbreviate that with argon core if we like, which would be followed by 4s2, 3d10, 4p3. So now to talk about quantum numbers, let's get rid of the periodic table. We want to know the quantum numbers associated with the electrons in the highest energy subshell. Now remember, according to the Aufbau principle, these orbitals are filled in this order because they are increasing in energy. Each next subshell is higher in energy than the previous. So the highest energy subshell is the 4p subshell. So let's draw out the 4p orbitals, and those are going to look like this. So there are 3p orbitals for each energy level. And if we have 4p3, we have 3 electrons that we need to put in them. Remember that Hund's rule tells us that we're going to put 1 in each orbital before doubling any of them up. So the 3 4p orbitals each have 1 electron, and they will all be aligned in spin. They will all be spin up. So now that we have that, let's go ahead and assign all of our quantum numbers. The first quantum number is the principal quantum number, n. That corresponds to the energy level. That one's very easy because whatever we have, 3s2, 4s2, 4p3, etc., that first number, that is n. So because these are 4p orbitals, n must be 4. Now let's look at L. L is describing the type of orbital. So if we are looking at an s orbital, the L value would be 0. For p orbitals, the L value is 1. For d orbitals, the L value is 2. For f orbitals, the L value is 3. We are looking at p orbitals, specifically 4p orbitals. That means the L value must be 1 for all of these electrons. So that covers n and L, and those will be the same for all of these electrons. Now we get to a point where the remaining quantum numbers may be different for each electron. Remember, m sub L goes from negative L to L. So if L is 1, m sub L can be -1, 0, or 1. And those correspond to each individual orbital. Now each of these electrons is sitting in a different orbital, so each one will have a different m sub L value. So the first one can be m sub L equals -1. The second one can have an m sub L value of 0, and the third one can have an m sub L value of +1. Lastly, for m sub s, that's the spin quantum number, that has got to be plus 1/2 or minus 1/2. And since all of these must have their spins aligned, we are going to assign them all spin values of plus 1/2. So that is all set for the quantum numbers. All of those have an n value of 4. They all have an L value of 1. They each have their own m sub L value, and then they all have m sub S values of plus 1/2.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.